Okay, so on this question, they're giving us a graph, a picture. There's a line. And they want us to write the equation. Write the equation of the line, of this line. How do you do that? How do you look at a picture, a graph of a line, and work backwards to the equation? Like, what is the equation that produces this line? Well, remember what we've learned? Y equals mx plus b. Remember what the number out here is? It's the vertical y-intercept, isn't it? It's the vertical y-intercept, which is right there. So that's -3. We got that. So that's y equals mx minus 3. We good so far? We got that part of the deal. Now we just need that m in the front. What's the m, and how do we find the m? Oops, sorry, I'm moving the thing there. Remember how we find the m? The m is slope. It is rise over run, isn't it? Remember the fraction in front of x, or whatever's in front of x, is slope. It's rise over run. So, well, how do you know that? Well, you just look on the graph and you find 2 points where it hits on the grid lines perfectly. Here's one. You see why I chose that? Right here, it doesn't hit right on the crosshatches. It doesn't hit right between 2 grid lines. And here it kind of misses. But here, it's right on. Here, I can back it up, show you a little bit. See how it hits right on? It's really clear where that point is, and then really clear where that point is. So just pick any 2 points that are really, really clear so you can see exactly where they're at. Right here. Okay, and then just count rise over run between those 2 points. So here we go. 1, 2, that's down 2 as a rise, and 1, 2, 3 over 3 for the run. So the slope, the rise over run, is between any 2 points in the graph. So that's going to be down 2 over 3. So the slope in the front there is down 2 over 3. Like that. And there's our equation. Just type that in. Now you can put the x on the top if you think that looks weird. I don't want. That's fine. You can put the x on the top if you want. Oops, minus. It's either one of those are the same. These are exactly. It's the same whether you have the x in the front or the x in the top. It matters not. They are exactly the same. Now you might wonder, well, how do you know that? Because anything alone is over 1 is the same as being in the top, isn't it? Remember that? That's true. That and just, I mean, that's just simply a true statement. If I write 7, like, oh no, I meant 7 divided by 1. Well, that's the same thing. If you take 7 and divide by 1, 1 goes into 7 times. They are the same. So my point is to put something over 1 does not change it. You see that? That's not just style. That's truth. Math is about truth. That's just true. Anything divided by 1 is the same as itself. 7 divided by 1 is 7. So in the same way over here, x alone is the same as x over 1, which means it's really in the top. That's why it's the same to put it in the top. So my point is either way, it doesn't matter. In the front, in the top, the x can be in the front or in the top. It's all the same because anything alone is really over 1 is really in the top. All right, anyway, enough said about that. Did you understand how I did the slope here? So one more time. So then you find out where does the line go through the vertical axis, the vertical y-intercept? That's -3. That's the number off to the right. And then how you get the slope in the front, slope is rise over run. So you just get any 2 points that are clearly on the graph, and you go rise, run between them, down 2 over 3. Now you think, any 2 points, you mean you could have grabbed like the one, like, how about this one? That one's clear. There's a clear point. Yeah. Down 2 over 3. See, it's the same thing. Down 2 over 3. In other words, that's what the line keeps doing. Down 2 over 3, down 2 over 3, down 2 over 3. That's the slope of the line. It just does that forever. So grab any 2 points you want that you can clearly see where they cross on the line, and then just do the rise over run, because that's what slope is, rise or run between them. Down 2 over 3. That's the fraction in front of x. And there's our equation. There we go.